Okay, Notes Chapter 6, Section 4, Part 3. Sad thing is, this is our last note sheet from our textbook. So I hope that you have enjoyed the class and all of the things that we did this year. Applications of matrix inverses, decoding. A cryptogram. Is a message written so that no one other than the intended recipient can understand it. To encode a message, we begin by assigning a number to each letter in the alphabet. For instance, A is 1, B is 2, C is 3, and so on till we get to the letter Z, which is 26. And a space in between words equals 0. The numerical equivalent of the word math is 13, because M is the 13th letter in the alphabet. A is 1, T is 20, and H is 8. The numerical equivalent of the message is then converted into a matrix. Finally, an invertible matrix can be used to convert the message into code. The multiplicative inverse of this matrix can be used to decode the message. All right, so let's see what we have here in our box. These are the steps to encoding a word or a message. You will first express the word or message numerically. Second, you're going to list the numbers that you got in step 1 by columns. This is the only thing with the matrices that we do in this course anyway, where we do the columns first. Everything else is row, right? Matrix multiplication is row by column. But here, when you convert your alpha matrix into a numeric matrix, you have to do it in columns. And it's important to know that you need a square matrix, an n by n, 2 by 2, 3 by 3, 4 by 4, etc. If you do not have enough numbers to form a square matrix, put zeros in any remaining spaces in the last column. Then we're going to select any square invertible matrix called the coding matrix. The same size, has to be the same size as the matrix in step 2. So if our numeric matrix is a 3 by 3, you need a coding matrix that is also a 3 by 3. Multiply the coding matrix by the square matrix that expresses the message numerically. The resulting matrix is the coded matrix. So by doing that, you scramble the message. Use the numbers by columns again And the coded matrix is step 3 to write the encoded message. All right, an actual example. All right. Use the coding matrix, -2, -3, 3, and 4, to encode the word base. Well, I'm going to write my word base in a column. B is the second letter of the alphabet, A is the first, S is the 19th, and E is the 5th. It would help if you memorize some of the letters and what their numbers are in the alphabet. For instance, E is really common. It's like one of the most used letters in the alphabet in the English language. And so I have memorized that E is the 5th letter of the alphabet. I have also memorized that M is the 13th letter of the alphabet and J is the 10th. And I know, a little silly thing for me, I like Michael Jackson. His initials are MJ, and so I know MJ is 1310. It's just a little fun I do in my head. So now when I convert this into a numeric matrix, it's got to go in columns. It's 2, then 1, then 19, then 5. So that's one thing new you have to remember to do. Instead of going across the row and jumping to each successive row, we're going to go down the column. 2, 1, 19, 5. All right, from the step above, to encode or scramble the message base, we need to take the coding matrix and multiply it with a numeric matrix in that order. Remember, matrix multiplication is not commutative. And when we multiply those two, we get the encoded message matrix. Okay? It's alphabetical. C first, then N. All right, it's the coding matrix times the numeric matrix is going to give us our scrambled message. So let's take the coding matrix and the word base, 2, 1, 19, 5. And we're going to multiply these. -2 times 2 plus -3 times 1 2 by 2 with a 2 by 2 is going to be a 2 by 2. It doesn't matter how we set this up. I could do -2 times 19 plus -3 times -5. Not -5, +5. That takes care of row 1 with column 1 and column 2. We'll do row 2 with column 1, 3 times 2 and 4 times 1. And row 2 with column 2, 3 times 19, 4 times 5. You can get a calculator. It's -4, -3. This value here is -7. 6 and 4 is 10. -38 plus -15, -53. And here we've got 20 plus 57 is 77. So our encoded message or scrambled up message and we have to go by columns again, -7, comma 10, comma -53, comma 77. Now you should realize this is encoded because the letters of the alphabet aren't going to have any negative, what do you call it, placement of converting this from numeric to alpha. Okay, so again, what did we do? We took our word or our message, base, we assigned values to them, to the location in the alphabet, and we put them in a matrix and columns. I knew I needed a 2x2 because this was only 4 characters. Now, if you have another word like, I don't know, terrific, all right? So this is just like an example. If I have the word terrific, I have to count the number of characters. 1, 2, 3, 4, 5, 6, 7, 8. 8 characters. I would need a 3x3 matrix, since a 3x3 has 9 spaces. I would use 8 of those spaces when I convert my alpha into numeric, and I would have 1 space left over in the matrix, and I would insert a 0. Okay, so 8 will be used. Use a 0 for the last character. So it just depends on how many values you need in your matrix. Okay, so you have to count them. If it is a phrase, then you have to use spaces, and then you're going to use zeros in between. Okay, so if you have any questions on that, let me know. I'm going to go to side 2. All right, decoding a word or a message that was encoded. So now we're going to want to, and this is what your quiz is going to be on, you're going to decode a message. Find the multiplicative inverse of the coding matrix. You will have to be given the coding matrix. And so then we're going to find the multiplicative inverse of that coding matrix. And the next thing we do is multiply the multiplicative inverse of the coding matrix with the coded matrix. Okay, so that's your matrix multiplication. And then you express the numbers by columns from the matrix in step 2 as letters. So this is just a basic example. We're going to decode the word that we encoded in example 6. So decode, -7, 10, -53, and 77. All right, first thing we have to do is find the multiplicative inverse. Now, because this one's pretty basic and it's only a 2 by 2, we are going to use the quick method to find the inverse of a 2 by 2. Now, on your quiz, it's going to be bigger than a 2 by 2, and so you have to use the augmented matrix. You remember from the notes, you'll have to set up matrix A, which is your coding matrix, and make it an augmented matrix with the multiplicative inverse matrix next to it, and then perform those row operations to make the matrix look like, reduced row echelon form on the left, and a second matrix B, and then B would be equal to inverse A. Okay, so for those problems where it's larger than a 2 by 2, you'll have to do this. So this is for 3 by 3 and more. Okay, 3 by 3 plus 3 by 3, 4 by 4, 5 by 5, etc. But because our coding matrix is only a 2 by 2, we're going to use the short method. So find the inverse of the coding matrix. And the coding matrix is -2, -3, 3, and 4. This was given to us. It's a 2 by 2. So we're going to use the shortcut. Inverse A is equal to 1 over AD minus BC times the matrix D negative B negative C A. Alright, now we're going to substitute into this. A is -2. D is 4. Subtract is subtract from the formula. B is -3. And C is 3. Multiplied with, remember you switch the A and the D for -2. And then you negate these. So this would be -3 and this would be +3. Alright, let's take care of what's in the bottom here. This is -8. This is -9, but -8 minus -9 is really -8 plus 9, or 1. Pardon my bells. That's my signal to open a Google Meet. Sorry about that. And of course, this doesn't change. So inverse A is this matrix here, 4, 3, -3, -2. All right, we need the inverse so that we can multiply and decode the message. All right, so I'm going to move my paper up. And we're going to write decode. So it's the inverse of the coding matrix times your encoded message, or the coded message, and that's going to equal your decoded message matrix. All right, so we got our inverse matrix with our message matrix, and it's going to decode that for us. So just remember, it's always the coding or the inverse of the coding first. All right, our coding inverse, we just found that above. That was 4, 3, -3, -2. We're going to multiply that with the encoded message, which was -7, 10, -53, and 77. Again, it should make sense to you that this is a scrambled up message because of the negatives and because of the large numbers, right? A numeric message would only have the highest value being 26. Okay, the rest is just matrix multiplication. So 2 by 2, excuse me, with a 2 by 2 would be a 2 by 2. This row with this column is 4 times -7 plus 3 times 10. This row with second column, 4 times -53 plus 3 times 77. Second row with first column, -3 times -7, and plus -2 times 10. And second row with second column, -3 times -53, plus -2 times 77. Okay. Calculator may help you. When you type these into the calculator, you're going to get 2 and 19, 1 and 5. Remember, we now go down the columns, right? First column, then you bump over to second column, top to bottom. 2, 1, 19, 5. 2 is B, 1 is A, 19 is S, and 5 is E. And there it is. Forward and backwards. Oops, I guess I wasn't showing that as I was writing it. All right, so again, we go down the columns. 2, 1, bump over to the next column at the top, 19, 5, write our list, and then convert to our alpha and end up with the word base. Okay, so I'm actually going to get one of my matrices that you're going to see on your practice quiz and show you what that's going to look like, because it's going to be bigger than just the 2 by 2. All right, so one of my examples, and this is not one of your practice quizzes. It could be an extra one if you would want an extra one. Here, you'll be given a coding matrix, and then you'll be given up a scrambled up message. Okay, so I have to find the inverse of the coding matrix and then multiply it with the encoded message to descramble it. Okay, so notice this is not a 2 by 2, so we can't use that quick way of finding the inverse. You're going to have to actually do row operations. So I'm just going to zoom out here. It's not like in the pencil on the zoom out. All right, so I have to take my coding matrix and write it as an augmented matrix. Here's A, and then here's I. That's your multiplicative identity, with 1s down the diagonal, 0s everywhere else. And then you'll have to go through these series of row operations, right, to get this to be a 1, and then you use the 1 to make those be 0s. And then you move in, and you make that be a 1, get those 0s. And you move in, you get that to be a 1, make that a 0. You move in, you get this to be a 1. And then you have to work backwards. You're going to use this 1 to create a 0 here, unless there's a 0 there already. And then you use this 1 to make those 2 be 0s. And then you use this 1 to make those 3 items be 0s. And so you go through this process of these row operations, and it is a little bit of a process, but not undoable. You've done the row operations before, and you know what reduced row echelon form is. So we go through this process until we finally have the inverse of the coding matrix. Right? Now, yes, you will get some ugly fractions sometimes with some of these. All right, maybe I can zoom in and see it better. Okay, so you will get some weird looking fractions. And then you'll have to take it a step further and do inverse A times B. Okay, well, you have a calculator. Do your row operation. I recommend you do this times this and get the value and put it there. You have a calculator, convert it to fraction, you know, math enter, enter. It's probably going to be easier for you to type that into the calculator than to type in all those decimals, especially if you like to round. You don't want to round anything, okay? So use the fractions, and then use the calculator to add. So again, I would do, you know, negative 1/16 times 42. Do that on the calculator, math enter, enter, and that's negative 21/8. Plus, do negative 1/48 times 33, math enter, enter, negative 11/16, plus 13/48 times 15, math enter, enter, 65/16, and so on. And then when you're done here, then you can add these on the calculator, do math enter, enter. Well, you shouldn't have to do math enter, enter, because these should all be integers. Okay, and then you're going to convert from numeric to alpha to get the saying or the phrase. Okay, so if you have any questions on that, please let me know, and I will be more than happy to help you. If you're at home, pop in a Google Meet. All right, so exciting. This is some fun stuff here. I feel it's fun stuff anyway. All right, have a great day and have lots of fun with this.